All right. So the first set of parameters is same as before, and then we have the variables that again is the same as before. Now we have what is called interactive. We can, by clicking this, we will come to this. We are not going to do this right now. We will come to this in a little bit. You can build the decision trees in an interactive way. Okay, and so splitting rule. So this is what we've been talking about for a while. So we have three different default splitting rules that are possible. Okay, one for interval target, one for nominal target, one for ordinal target. So this is target. So here in this particular example, what we have is a nominal target. Okay, so target is binary. So this is binary target, which is nominal. Okay, so okay, but so here are the options available. If it is the interval target, okay, so interval target would be like what, instead of 0 and 1, you will have an actual value. For example, median value of the median home price. Okay, so the prediction here would be for a particular leaf node that you've reached, you will find the average of the y values and use that as your predicted value. So in the case of interval target, the two possibilities are there. You can use variance as the splitting criterion. So instead of Gini, so the Gini and entropy is only for nominal or ordinal target. It's not for interval target. For interval target, you can use mean square error, so which is like the variance, or probability of f would be like chi-square probability of f. So you will look at ANOVA kind of situation there. Okay, so and then you will compute the probability of f there. If it is nominal or ordinal, so you have in the case of ordinal, you have entropy or Gini. In the case of nominal, you have entropy, Gini, or probability of chi-squared. Probability chi-squared is the log work that we talked about. Okay. So the default is probability chi-squared for nominal target, but you can change it. You can change it to entropy, or you can change it to Gini, one of the three. Okay. Now we'll leave it at Gini. Now significance level is for the default is 20%, and that is only if you select probability of chi-squared as your splitting criterion. Okay. So in the case of interval target, of course you will have probability of f as the default. Okay. But if you use variance, then this doesn't matter. What you put here doesn't matter. In the case of nominal, if you select probability of chi-squared, then this significance level will be used for determining whether the split to be carried out or not. Okay. Now missing value, again you can select, you can elect not to use the missing value, or you can use it in a particular way. So here you can elect to send the missing values to the largest branch, the branch with the most records, or the most correlated branch. Okay. So using the largest branch is the default, I think. Use input once. So a given input variable, you want to use it only one time. Okay. That would restrict the number of splits that you have to deal with. Okay, it will limit the depth of the tree, which is a good thing, but then by limiting the use only once, then you are actually limiting yourself in finding pure leaves. So it is not a good idea to limit it to just one time use. So use input once is usually, the default is no, but if you want, you can limit it. Okay, maximum number of branches, so this 2 means there is only binary search. You're going to look at only binary search. Okay, but you can change it, you can increase it to 3, 4 or whatever. Okay, but binary is good enough. So binary search is what is usually done. The maximum depth, again, this limits the number of iterations that you have to go through. So a tree will not be allowed to grow by more than 6 levels. The maximum categorical size here, this is one of the ways to limit, one of the strategies to limit the complexity, computational complexity that we talked about in last time, I think. So minimum categorical size is if you have a nominal or ordinal input variable, and if a particular level has only less than 5 observations, less than 5 records, then that category will be eliminated. It will be replaced either with a missing value or some other option. Okay. And here you can also look at node size. So if a leaf size is, minimum leaf size is given as 5. Okay. If a leaf has less than 5, then that leaf will not be included in the tree. The number of rules. Okay, so here this is about surrogate rules. So suppose in case there is a missing value, you can, if you are not able to use a particular rule in a node, then what is the other rule that you could use? A surrogate rule. So we don't have to go through that in detail now. So these are the options. Okay, so the subtree options are important too. Subtree options are the ones by which you prune the tree. Okay, so you don't want too big a tree, because too big a tree means you're overfitting. You're fitting. So if you go through the process long enough, you could ultimately get to a stage where all the leaves are completely pure for the training set, not for the validation set. Okay, you could possibly do that, and in that case you're only fitting the noise and not the signal. So you have to back up a little bit and prune the trees, and these are the ways in which you prune the trees. So subtree assessment, largest and n. So these are, if you select largest, then the largest tree would be generated. Okay. Tree that is completely expanded. N would be a particular size. You say, okay, this is the size that I want. Now assessment is the default, where you can then say you use the assessment that I select. Will be assessment measure here. You can select the assessment measure you want. Okay, decision is the profit and cost matrix that we talked about. Okay. If you set the decision parameters in the data source, okay, what is the benefit of true positive, what is the cost of false positive, and if you have that information set up, okay, at the data source, then decision makes sense. Otherwise decision doesn't make sense, because that would be decision. Average squared error is usually a good measure to select if you have interval target. If it is interval target, you would use that, or you can use misclassification rate for pruning back. Lift would be to look at you list them by the misclassification rates, by smallest to the largest, and then select the ones that are best. You look at the top 25% or top 20% cases only, and then make a selection. So if you have decision parameters, I would choose decision here. Otherwise, normally you go with either one of these two. If it is interval target, you will use average square error. If it is nominal target, you will use misclassification rate. Okay, so now let's run the decision tree with these selections. So we have Gini index here for nominal target, and we are using assessment method for subtree, misclassification rate. And run the tree. Okay, look at results. Of course, the classification and stuff like that are here, like always. Okay, and now let's look at the tree here. Okay, now you see that we have a much larger tree than what we saw before. Okay, and again, you may not want to keep this larger tree, because you see that there's a lot of impurity. Even though you have a larger tree, I don't know whether you're gaining very much in terms of accuracy.